Hello everyone, today we're going to install the Euclid Probe. I've been using standard induction probes, but frankly I'm tired of waiting for them to stabilize. They seem to change based on the temperature that exists in and around your printer, and frankly I'm not finding them all that accurate. In the case of my printer, it takes an hour and a half to almost 2 hours for things to stabilize. So I've had enough. It's time for something new. So I'm well aware of the Clicky probe that many have been using, but I decided to go ahead and purchase the Euclid probe. It's about $25. The kit, it's really not that much money compared to what other probes tend to cost. And I really like the idea of having a circuit board. And so I decided to purchase the kit, and here we'll build it. Here I've opened a package. You can see the circuit board. It comes with the magnets, 4 of them to be exact. And it comes with all the screws you need, the connection hardware, basically everything you need to put this together. Now you'll need to 3D print a few parts, the first one being the mount. And as you can see here, the circuit board slips right in. Of course, the circuit board will be cut in two, and that's what holds the probe. You'll also need to print, in this case I printed this adapter. It mounts like the standard induction probe, but the circuit board will mount to it. And then there's this really handy guide to help with soldering and placement of the parts. To install the mount, you'll need a couple of M5 bolts, and you'll also need M5 T-nuts as well. First, we need to solder the socket and the micro switch onto the circuit board, and for that we'll use the guide that we printed. As you can see, the circuit board fits in nicely, flush. There are multiple options here for this tool. This is the one with the 2mm tolerances. You can choose wider tolerances if your printer can't print to those tolerances. As you can see here, the socket fits where the outline is, and the same thing with the micro switch. And so these two pieces will actually be inserted inside the tool that we printed to aid with placement and soldering. And so here I'm inserting the micro switch, and I insert the socket as well. And then make sure you place the circuit board with the outlines facing down, like so. And make sure the circuit board sits flat into the recess of this 3D printed guide. If not, it won't be flat against the micro switch, and it's really critical that that micro switch is completely flat, solid against the circuit board. Now when you solder the pins, don't do what I'm doing here. I'm starting on one side, moving all the way to the other, and the instructions clearly state just solder the center pin initially, pull out the circuit board, and then check it to make sure everything is sitting flush, everything is straight, make any adjustments you need to. Then you can put it back in the guide and solder the rest of the pins. Once you've completed soldering, you can take it out of the guide and then snap the two halves apart. Your hands work pretty easily. And then here I'm just using a standard set of pliers to take this center tab off, which is not needed at all. And I'm just going to use a sandpaper to smooth off the edges, which should make it fit a little easier in the other 3D printed parts that we're going to attach these to. Now we're going to install the magnets, and we take the aluminum magnet mounts here, or nuts actually, and the widest part of these actually goes down into the plastic first, with the thinner end up top, which the magnets will sit on top of, and the screws, of course, will screw into. And here we're placing the circuit boards back in, and make sure everything is sitting nicely and looks centered. And then here I'm taking the magnets along with the screws. I'm putting the screws in first because the magnets seem to hold them pretty nicely. And do note north and south here, and tighten these in. It's a little bit tricky. These magnets are really strong. Once you have them firmly tightened, you can pull this out and pull off the magnet holder. In this case, it was a little bit tough. And then take a close look. The magnets should look really nice. And again, we want to make sure the next set of magnets we attach align properly, meaning both pointed ends of the circuit board align. And so here I'm checking just to be sure. And then tighten the screws on this side as well. And again, firm but not super tight. You want to be careful. The magnets can break. They're really brittle. And then once you're done, take off the plastic carrier. And then check to make sure they sit nice against each other the way they're supposed to, and very flat with no play. And it should look just like this. And so now we need to make the cable. I had to cut my Voron probe earlier to install it, and I had all this extra cable, and the colors are right, and so I figured I'm just going to go ahead and use this. So here I'm crimping on the ends, and I'm not actually going to show you all of these, but here I'm going with one of them. And just go ahead and do all three, and then attach the connector. So connect the brown wire to the VCC pin, connect the blue wire to the 0 or the ground, and then attach the black wire to the signal in. And so here I'm just inserting the other end of the plug without the pins yet, and just making sure I know exactly where these are going to go in. Again, brown VCC, blue ground, black signal in. And then just insert them in until you hear the click. And here's the finished plug. And as you can see, I have some heat shrink tubing that I'm about to shrink here as well. So on the circuit board, just to eliminate any possibility of shorting or causing problems, you need to go in, and I already did this, trim any of the pins that are sticking out that you've just soldered to make it as flat as possible, and then put some sort of insulation on top of it. In this case, I'm using Captain tape, and I don't think heat's going to be a problem, but still it's a really good insulator, and it should protect this from shorting out in any way, shape, or form. And I went ahead and did it to both sides. Next, we have to mount the probe receiver to the adapter where normally the Voron probe would be inserted in the print head. And I printed the version that had the larger holes because that aligned best with the screws that came with the kit. And just be sure to check and measure, and this simply bolts in place. Screws in place, excuse me. Make sure the power is turned off on your printer for the next part to make sure you don't damage your probe. So next you need to disassemble your print head, pretty much like this. And here I've already inserted the probe, bolted it in. I've also cut the cable to length, and then I've also gone ahead and crimped the connector on as well. And again, this should match exactly the Voron probe that came before it. The The brown matches up to the red, the blue to the blue, and the black to the black. And that should pretty much cover the installation of this probe. And then just go ahead and reassemble the print head. Next, we need to install the probe mount or the probe holder for when it's not in use. Here I've added some screws that were adjustment. It turns out I didn't need them, but again, these are going to use the M5 nuts and the M5 hex bolts to mount to the same rail, the left side same rail that your print bed is connected to. We start by inserting the two T-nuts into the rail, then secure it to the T-nuts with the two M5 bolts. So I'm going to leave these bolts loose enough so I can adjust the position a little later. I'm going to align it based on what happens when the printer moves to the home position. There are two versions of the probe, a 24-volt version and a 5-volt version. However, the 24-volt version was out of stock, and so I have the 5-volt version. So just so you don't burn out the LEDs on the probe, you do need to go in before you turn on any power here and switch the Z plus outlet, in this case on the spider board, from 24 volts to 5 volts, and here you can do that with the jumper. So turn on the power and home your probe, your 3D printer. Insert the probe part with the micro switch into the holder with the micro switch facing down, magnets facing up. Then carefully, using the printer controls, either from the control panel up front or from the web interface, jog the print head over fairly close to the probe, and we're going to use this step to align it to make sure the probe is sitting in the right position, so when the print head is directly over it, it can collect it. So I've aligned it visually by looking at the screws that are in the magnets of both the one that's sitting in the holder as well as the one that's sitting on the print head. And you really want them to be aligned when you're looking at them from the side like this. And once you have those adjusted, you can go in and tighten the M5 bolts to fasten or to secure this holder in its place. Once you've done that, write down the coordinates. That'll be your initial position where you want to move the print head just in front of this holder. And then go ahead and go back to the controls again, and now jog it a little bit more. So this time you can move it ahead and make sure the receiver with its magnets is aligned directly on top of the magnets of the microswitch probe itself that's sitting in the holder. And once you have those really nicely aligned, it doesn't have to be exactly perfect, but it should be pretty close. The magnets will take care of any play. So then go ahead and write down this set of numbers because this represents where the print head is going to sit on top. Once you've got those written down, use your controller again, and this time jog the Z-axis, moving the gantry down, getting closer and closer until it makes a connection and the magnets attach to each other. So you can see this still could use a little more alignment. Do a better job than I did. When the LEDs light up, an electrical contact is made and you're pretty much where you need to be. And so now write these coordinates down as well. Again, you'll be using this in the configuration. Now go ahead and jog the print head so it can pull the probe out of the holder. And once it's out of the holder, start jogging the Z-axis back up again so you can find a height where the tip of the micro switch, the contact switch itself, clears the bed. I apologize, it's blurry here, it's hard to see, but once you've got it above the head, you need to write down that Z coordinate as well, because again, we'll be using this for configuration. Now we need to measure the distance between the center of the nozzle and the center of the probe which should be the center of the screw head. And get about as close as you can. You'll find this is actually documented elsewhere. And then we need to go ahead and measure the distance in height from the one side of the micro switch, the flat side of the micro switch, again, to the head itself. There are some other ways you can do this. This is fairly crude, but again, I'm assuming this is going to be pretty much like everyone else. I just want to make sure I'm fairly close in the ballpark. So now we get started on configuring the firmware with all the information we've collected. In the GitHub for Klipper, we go into the V3 example, and I'm choosing it specifically because the V4 seems to be doing a whole heck of a lot more than I believe we need. I am copying this because I had a hard time downloading it, but anyway, I'm copying the text and then going into a text editor, creating an all-new file, and pasting that in, as you see here. This is an untitled document, but we're going to call it Euclid.cfg once we're done. And so just simply hit save, name it. And this will be where we configure the probe, and we'll make all our changes to here, but we do have to make a couple others to the printer.cfg file. Here I'm using the fluid interface, and if you hit the plus up here at the top, you can upload the file. Here you can see I'm selecting the Euclid.cfg I just created, and it uploads it and saves it to your Pi for you. So the changes are really quite simple. So first thing, you got to add the include.euclid.cfg file, which is the file we just created. And again, we're doing this in the printer.cfg file. That'll include all the instructions when the Pi is reading this file to parse it. And then we scroll a little further down and we go to the probe section, and in the probe section, the X offset was probably already 0. The Y offset is probably already 25. However, this Z offset was 0, bumped it up to 9.5. Speed, dropped it down to 5 from 10. I actually used 2 during testing, and I added this line, lift speed, for 10. And I added some comments here just to remind myself, and in case I ever want to go back and move back to induction. Now in the Euclid.cfg file, scroll down, and the probe section, make sure this is all commented out because we're using the probe section in the printer.cfg file. See, by mistake, I left one in here. And then we scroll down a little bit further, and there's the homing override. You should make sure this is commented out as well. We won't be using it. These other macros are fine until we get to the G-code macro M401. And in this case, we're definitely going to make some changes, and it's going to be based on the numbers we wrote down earlier. And so I commented out the first 2 lines of G-code. They're just not needed. And if you want, you can add to the comments. This next one, X77Y350, this position is special because it's right after a home. I move all the way over just to the beginning of the dock, just before I start my operations. This will act like basically a collection point where you can safely go anywhere with the print head and then start the operation. I commented out the G4 code. On the G0, X46, Y350 are again the numbers I wrote down, which now move the print head directly over the mount. M400 I leave alone, and here you can see I'm dropping Z down to 1.8, so I can touch magnets and start to move from there. I leave M400 alone. I left the G4 here. It's probably not needed, but hey, I left it. It was there. And then here you can see where I move back out the G77. The magnets have touched, so let's move the probe out of the holster, and that's what I'm doing, and I'm moving to that safe spot that I identified earlier. And I also had to move the print head up to 20. I found in some cases the probe would sometimes hit the bed, and that just made it a little bit safer. And then we scroll down to the G-code macro M402. And as you can see here, I've commented out the first 2 lines of G-code. And I'm basically using the same numbers I used before, just a little bit different order. So again, X77 to my spot after a home. Here I move the print head down first to 1.8 because we want to insert it into the holster. That's where the slot is. I move M46 all the way over to the left to make sure the probe is in the holster. I left the M400 alone. I commented out this G4 code, didn't really need it. And then here you can see I'm moving the print head up to 20. So I want to disconnect or separate the magnets. And then from there, I move back into my safe spot to the right of the holster, and I comment out the next line. And that's it. So after hitting save, make sure you hit restart, restart Klipper rather, because you need both the printer CFG and the Euclid CFG to be reloaded with all the settings that we've made. And then I entered in, and then I did a home, which you see happening here. My apologies, it's blurry. And then once the printer homed, I entered in M401, and this was the result. And then I entered in M402, and this was the result of that. Once you've completed that test, it's really a good idea to go back and do everything up to and including the Z offset adjustment just to make sure everything's where it needs to be. So this is my bed readings with the Omron probe, and you can see it's a 0.18, I think it's 25. And here's the bed reading with the new probe, and it's 0.13. That's actually a huge difference just by changing the probe. If you found this video useful or helpful, please click subscribe.